At 3 a.m. on September 29, 2025, in the Karachev area of Bryansk Oblast, Russia. A low-altitude Podlet K-1 radar station on the outskirts of Karachev simultaneously registered an unknown contact from the southwest. The indicator lights on the control panel switched from green to yellow, marking an unclassified target entering the scan sector. The radar screen began to flash repeatedly. Return echoes appeared as blurred, unstable patches. The operator leaned close to the screen, rechecking speed and heading. A cluster of low-level objects was approaching on a 236-degree bearing. Speed, approximately 150 kilometers per hour. Altitude, 80 to 110 meters. RCS, highly variable, unstable, poor returns. The classification algorithm displayed large bird cluster over low profile, UAV threat level low. Thus, no alert was triggered, no escalation of the alarm state. But what the screen showed were not birds. They were a swarm of Decoy UAVs that Ukraine had dispatched, compact UJ-22 drones, modified from commercial platforms. They were designed to mimic the flight characteristics and radar signature of a wave of cruise missiles. Each drone was a provocative decoy carrying 4 simultaneous tasks: pull Russian air defense focus off axis, force Panzer, Tor, and S-400 units to activate radars, exposing their locations. Overload classification algorithms disrupt the intercept chain. Simultaneously send back a live map of actual air defense coverage to the Ukrainian command center. The formation flew at about 100 meters altitude, spaced 1.8 kilometers apart, heading straight for Karachev. At exactly 3:05, when they were closing on the real target, the electro-deedle plant at 17-kilometer distance, they emitted wide-band jamming pulses, causing the Podlet K-1 and Panzer fire control radars to display scattered echoes, as if a formation of cruise missiles were inbound. Immediately, the Panzer S-1 cluster at Karachev went to combat mode. The 1RS-2E fire control radar began tracking the strongest return within the decoy swarm. 1 minute later, 2 57 E-6 missiles left their rails, enabling command guidance seekers, but they lost track of their target shortly after launch. The continuous tracking algorithm slid off because the decoy UAV's RCS fluctuated in rhythm by design, combined with their zigzag flight path, forcing the tracking radar to update steering angles constantly. Each heading change skewed the illumination beam, so the tracking system no longer had a stable return to maintain an engagement vector. At 3:06 minutes and 30 seconds, both interceptors detonated prematurely in the air. No effect. An officer on watch blurted out, "Can't lock, decoys." No one would confirm. While Russian radars still wrestled with the expanding decoy swarm radiating east of Karachev. 2 TEL launchers hidden under the forest canopy 40 kilometers apart in Sumy Oblast simultaneously fired 4 Neptune cruise missiles. Each warhead carried up to 200 kilograms of semi-armor-piercing explosive designed not to demolish a whole building, but to perforate, burn from within, and render an industrial system uncontrollable. Each launcher completed its firing sequence in under 10 seconds. Neptune 01 and 02 left Launcher 1, separated by 0.8 seconds. Neptune 03 and 04 were launched 1 minute 30 seconds later from Launcher 2 on a 41-degree offset axis. Their target was the electro-deedle manufacturing plant, Karachev, Bryansk Oblast. Electro-deedle is a critical military-industrial node producing components for more than 20 Russian defense enterprises, including cruise missile systems, Nebo-M radars, and Orlan 30 UAVs, plus control electronics, radar subsystems, and missile components. Internal technical reports from 2022 recorded that 70% of mid-tier Russian connectors, from Bars 1 communications to thermal sighting modules, were manufactured at electro-deedle. Destroy the right technical nodes, and the entire assembly line can be disabled for months, even years. The 4 missiles divided into 2 independent attack groups, approaching the plant from 2 cross-flank directions to create intersecting attack angles, beyond the simultaneous reaction capability of any single Pantsir or Tor battery. The entire flight path had been pre-programmed using the real air defense footprint that the Decoy swarm had just forced Russia's radars to reveal within the previous 4 minutes. What looked like dispersed interference was in fact an active reconnaissance phase, determining the orientation and reflectivity characteristics of each air defense node. It allowed the Ukrainian targeting team to compute the gaps between radar cover layers where Neptune would glide in unseen. All 4 missiles flew close to the ground, holding altitudes between 35 meters and 42 meters, entirely beneath Russia's radar horizon. Cruise speed for each missile remained between 875 to 890 kilometers per hour, faster than a helicopter, slower than a fighter, but leaving less than 45 seconds for a reaction if detected at 10 to 15 kilometers. The entire trajectory was guided by a suite of asymmetric technologies: TERCOM, terrain-matching navigation against a digital map to keep the route precise; low-resolution infrared satellite imagery, identifying targets by thermal contrast; integrated thermal camera DSMAC algorithms using micro-image matching to fix strike points. When Russian air defenses were still locked onto the Decoy swarm, these 4 missiles crossed the border from the southwest, where no Russian AD unit was actively tracking. At 3:06, all 4 Neptune entered the radar dead zone. They hugged the Bryansk forested terrain under 42 meters. Neptune was now less than 30 kilometers from the electrodetal plant. At near 900 kilometers per hour cruise speed, less than 2 minutes remained before impact. At 6 minutes and 14 seconds, the 1 RS-2E fire control radar of a Pantsir recorded the first intermittent return. A weak trace appeared to the southwest, an axis that had been neglected for 4 minutes. The signal flickered. Reflectivity barely rose above background noise. Estimated speed: approximately 249 meters per second. Altitude: approximately 40 meters. No IFF, no course change, no active radar pinging. The watch crew could not identify it, but instinct whispered, "Something is coming." Only 4 seconds later, Tor M2 in the industrial southern defense cluster raised a level 1 warning. The active phased array radar spun quickly toward the west. Range to target 23 kilometers. Time remaining under 60 seconds. But the control team was still recovering systems after the Decoy launch. Power panels had just been rebooted. The battery crew was waiting for valid engagement data. Having been tricked once, Russian air defense entered an overcautious posture. No one dared classify the contact as a real missile or a residual scatter from the remaining decoys. At 36 minutes and 35 seconds, the entire electrodetal air defense cluster entered a semi-alarm state. Internal alerts lit up, but no one had enough certainty to act. Afraid of another false intercept, they chose to wait for confirmation, a decision that would be costly. At 6 minutes and 48 seconds. With Neptune 01 less than 2,500 meters from the target, the watch officers in Karachev finally grasped the reality. The weak radar blip was not interference, not birds, not a decoy swarm. It was a cruise missile closing at nearly 250 meters per second, due to strike in under 10 seconds. The air defense complex descended into chaos. The classification, verification, authorization chain could not complete in time. "Automatic! Engage point defense!" the commander ordered. Urgent. A battery of 2 A-38 M30mm close-in guns from the Pantsir opened fire. Rounds were swept along predicted lead lines, but the distance was minimal. Time was insufficient. No gun position achieved an ideal firing angle. As the guns began to fire, Neptune 01 entered terminal dive. Approach angle 17 degrees. Altitude, 28 meters. Speed, 245 meters per second. The missile had locked onto warehouse D4, storing thousands of connector batches for Russian military gear at 3, 7 minutes, and 6 seconds. The 150-kilogram semi-armor-piercing warhead punched through the thin corrugated roof right at the center of D4. The detonation occurred inside a closed volume. No vents, no windows, no pressure relief. Pressure in the warehouse spiked from 1 atmosphere to 13 atmosphere within 0.2 seconds. Shock waves hammered all 4 walls and reflected back to the center. Temperatures shot to 1,700 degrees Celsius. 5,000 connector batches, enough to outfit 40 Nebo-M radar sets or 60 Orlan UAVs, were reduced to ash in under 2 seconds. Seconds later, the D4 roof blew off like a pressure cooker. A 3 by 8 meter steel sheet was hurled over 70 meters before falling onto adjacent support buildings. Almost simultaneously, Neptune 02 struck from the south-southwest along a secondary service track. Its approach angle was 34 degrees offset from Neptune 01, a flank strike on the opposite side of the complex. Target, Auxiliary Technical Block K7. This section housed the 110 kilovolt transformer station powering the production line, the central compressed air cluster supplying pressure for welding, spraying, and molding. Rows of high-pressure gas cylinders, 18 to 22 atmospheres, stored in line. At 3 minutes and 38 seconds, Neptune 02 impacted the corner of the auxiliary building, at the junction between the power substation and the compressed air array. The fuse detonated after 0.06 seconds, tearing out the southern wall. 3 high-pressure industrial cylinders detonated in a chain within 0.7 seconds. Flame raced into unshielded industrial power cabling. At 3 minutes and 50 seconds, the complex lost power entirely. All sensors, controls, and internal distribution panels shut down simultaneously. Automatic fire suppression systems disconnected. Fire isolation valves did not actuate in time. While smoke from the first 2 blasts still hung in the air, Neptune 03 closed the final 18 kilometers at just 39 meters altitude, approaching from the northeast. This time the target was not a storage hall. It was the plant's heart. The main production workshop E3, operating 3 automated lines, precision spot welding, connector molding presses, and high-power PCB assembly. All lines ran on industrial power, continuously across 3 shifts, generating high heat and occupying open floor space. By now, the Northern Pantsir S1 had rotated back and was ready to engage. But classification algorithms were skewed by residual ground heat from D4, producing false thermal clutter. At 3:08 minutes, Pantsir fired its first 57 E6 with a time-to-target intercept window of only 3.4 seconds. However, Neptune 03 performed an abrupt 14-degree course deviation, skimming the edge of the workshop and exiting effective radar illumination. The tracking radar lost lock for 1.2 seconds. The interceptor detonated more than 60 meters off target, causing no damage to Neptune's composite skin, engineered to absorb basic blast impulses. At 3:08 minutes and 33 seconds, Neptune 03 struck E3. It pierced the roof in 0.03 seconds, delivering over 1,200 kilograms of penetration force. The semi-armor-piercing warhead detonated deep within the molding press core. Temperatures at the blast center exceeded 2,800 degrees Celsius, above the melting point of standard structural steel. The shockwave sheared CNC machine spindles, drove metal fragments back through the production line's control panels, and shredded programmable logic controllers. The compressed air cluster detonated 1.4 seconds later, collapsing the production framework in a progressive chain collapse. All equipment ripped from foundations in under 3 seconds. Thermometers at the transformer recorded radiant flux up to 360 kilowatts per square meter. At that intensity, polymers, wiring, and circuit boards ignite immediately within a 40-meter radius. Fire raced along shop floors, cable trays and unclosed ductwork, automatic valves never sealed. Within 11 seconds, E3 transitioned from a local fire to a fully engulfed production line, uncontrollable. As the entire plant burned, Neptune 04 approached from the north, following the 110 kilovolt transmission corridor. This axis avoided TOR-M2, which was still re-slewing toward E3. No unit tracked the rear approach. Its target, the C2 control building, the only digital command center left governing the rest of Electrodetal. Inside were production data servers, line PLCs, automatic fire suppression controls, and industrial sensor hubs. At 3:09 minutes and 7 seconds, Panzer launched 2 more 57 E6 interceptors, but Neptune 04 dropped to 21 meters beneath the radar's effective beam. Ground-induced false thermal wave effects made the return appear as background clutter. Both interceptors lost lock for 2.5 seconds and detonated in midair, failing to reach the target. At 3:09 minutes and 14 seconds, Neptune 04 struck C2. The warhead punched through 2 reinforced concrete floors, annihilating the server room on level 2. Explosion consumed every circuit board, storage array, PLC, foam suppressant reservoir, and pressure control unit. In 0.5 seconds, all production data, design drawings, and line control commands were erased. Less than 10 seconds later, the eastern wing of the plant collapsed. The twin high-pressure blast tubes formed a channel of flame down the technical corridor. Ceilings caved, red-hot steel beams fell. A gray mushroom cloud rose above 300 meters. Edge radiation measurements at the workshop recorded 620 degrees Celsius, hot enough to melt aluminum alloys. 3 minutes after the final blast, the Russian Ministry of Defense received an urgent report from Bryansk. The message read tersely, "Serious explosion and fire at a specialized production facility in the Karachev area. No mention of Electrodetal, no mention of Neptune missiles, no mention of UAVs." Yet in the military internal comms, the technical log stated bluntly, "Target struck by cruise missiles. Air defense failed to respond in time. Severe damage." Within 15 minutes, commanders realized this was not an accident. This was a deliberate strike. At dawn, independent open-source intelligence sources began circulating the first images from the scene. The damage extended beyond Bryansk. The attack triggered domino effects across Russia's electronics production chain. Nebo-M radars could not be assembled due to a shortage of signal connectors. Iskander and Kaliber launcher testing paused for lack of inline control assemblies. Domestic Orlan 30 and Shahed 136 UAV builds stalled for lack of electronic components. Bars 1 communications equipment, the inter-command voice/data backbone, faced supply interruptions. Indirect losses from disrupted supply lines, halted production, and restoration costs could exceed 80 to 100 million US when strategic impact is included. Russia's Western technical logistics temporarily lost a key node for connectors and control electronics, creating a real risk of localized collapse across UAV, radar, and mid-tier systems assembly lines. This was not merely a factory strike, it was a systemic cut, an operation calculated at systems level. With only 4 Neptune missiles, costing under 4 million USD in total, Ukraine generated in effect 10 to 15 times the material value destroyed. The damage was measured not only in money, but in time, in broken supply chains, and in shattered confidence. This strike proved that modern war is no longer measured solely by tonnage of munitions or bomb blast yield. It is shaped by supply chains, reaction latency, and the ability to identify and sever critical vulnerabilities.